Modern air conditioning, the technology that allows us to enjoy cool buildings when the weather outside is hot, relies on refrigerants, or fluids formulated with unique properties that allow it to evaporate and condense at temperatures and pressures created by a refrigeration system. The phase change from liquid to gas and back again affords the opportunity to extract heat from our interior building environments and discharge that heat to a hotter outdoor environment. While it might sound complicated, these processes have been around for over a century. Of course, the way we use refrigerants has changed over the past century and will continue to change in the decades to come, but they're likely to always be a staple in the HVAC industry. Cooling in buildings and spaces has been a desire long before modern air conditioners. Efforts were made in ancient Egypt to cool buildings by trickling water down reeds hung in windows. In ancient Rome, water from aqueducts circulated through walls to cool houses. The first electrical air conditioning systems large enough to cool a whole building were put into service in 1902 to address problems in textile mills and publishing companies. By 1915, air conditioning systems were made commercially available. By 1925, people flocked to air-conditioned movie theaters. The summer blockbuster phenomenon is largely credited to the addition of air conditioning in theaters. Prior to 1925, movie theaters were mostly empty during the hot summer months. By 1930, hundreds of movie theaters had air conditioning. Air conditioning became commonplace in the American homes by the 1930s, as non-flammable refrigerants were developed. Through the 1960s, many people viewed air conditioning as a necessity for business and homes. It's safe to say air conditioning revolutionized the way people think about internal environments. But back in those days, little thought was given to possible detrimental effects of refrigerants. Climate science emerges as a factor in refrigerant use. The 1970s saw the emergence of energy conservation as an influence on the efficiency of air conditioning equipment. The Clean Air Act of 1970 outlawed the practice of venting ozone-depleting substances, including refrigerants, into the atmosphere when equipment is serviced or disposed of. The goal at the time was to address the air quality concerns. In the early 1980s, scientists began to identify the link between chlorofluorocarbon refrigerants and ozone destruction. By 1985, the scientific community had identified the existence of an ozone hole over Antarctica, and the refrigerant landscape was about to shift significantly. After the discovery of the ozone hole and visual evidence from satellite imagery, policymakers around the world recognized that immediate action was required. Harmful ultraviolet rays were penetrating through the hole, and concern arose that this phenomenon could spread throughout the globe. Policymakers from around the world agreed to the 1987 Montreal Protocol, which would phase out and ban chemicals like the common CFC and HCFC refrigerants of the day, with high ozone depletion potential. These refrigerants release bromine and chlorine molecules that can exist in the atmosphere for decades. Worldwide regulations led to the introduction of zero ozone depletion potential refrigerants, and as a result, the condition of the ozone hole has stabilized, and hopefully, with further commitments to our environment, is on the road to slowly recovering. While the new refrigerants had zero ozone depletion potential, they did have other significant drawbacks. The 1990s brought increased understanding of global warming and how greenhouse gases limit the sun's rays to reflect out of Earth's atmosphere. Carbon dioxide occurs naturally in the atmosphere at a level of 200 to 300 parts per million, and it keeps the planet warm enough to sustain life. Scientists saw atmospheric carbon dioxide levels at 400 parts per million for the first time in 2015. This rise in carbon dioxide correlates to the past 200 years during the industrial age, powered by fossil fuel combustion. Future predictions of the effects of global warming prompted global action once again. Several chemicals account for global warming: methane, nitrous oxide, carbon dioxide, and fluorinated gases. Refrigerants are fluorinated gases. In 2015, the Paris Agreement was signed by more than 180 countries, which stated the goal of limiting the temperature rise of Earth's surface to 2 degrees Celsius. The 2019 Kigali Amendment to the Montreal Protocol, ratified by the US in 2022, seeks to reduce the use of HFC refrigerants to 15% of the baseline usage in 2016 by 2035. More immediate reductions are being implemented through 2025. The Significant Alternatives Policy, also known as SNAP, rules were issued by the U.S. Environmental Protection Agency, also known as the EPA, to phase down the use of R410A and R134A, but courts ruled EPA didn't have authority to do so. Some states in the U.S. began adopting rules to phase out HFCs, regardless of the federal policies. California requires refrigerants in the air conditioning systems to have a GWP value less than 750. The EPA was authorized in 2023 by American Innovation and Manufacturing Act to implement the SNAP rules and issue phased-down HFCs in alignment with the Kigali Amendment. The rules are consistent with the 1990 Clean Air Act. HFC 32 and other refrigerants are listed in EPA Rule 25 as acceptable for use in chillers. The rule states that beginning January 2, 2024, manufacturers must meet the requirements of new standards. Manufacturers of refrigerants and air conditioning equipment must evaluate competing factors involved with meeting regulatory requirements. Operational efficiency, toxicity, flammability, cost, and equipment size must be considered when choosing a new refrigerant and equipment design. In some cases, air conditioning equipment using more earth-friendly refrigerants may not operate as efficiently as the early AC equipment that used more harmful refrigerants. If an air conditioning system requires more energy to operate, it could potentially create more global warming, even though the refrigerant has a lower GWP. For this reason, criteria such as life cycle climate performance, or LCCP, which considers both direct and indirect emissions, are being considered. Typically, about 85% of an air conditioner system's climate impact is due to the operation, not refrigerant leaks, because the electricity source used to operate the system is often fossil fuels. Refrigerants can be categorized by the type of equipment. Medium, positive pressure for centrifugal and screw chillers. Low, negative pressure for centrifugal chillers. And high, positive pressure for commercial DX equipment, scroll compressors, and residential units. Different refrigerants are better suited to each category. Designing and implementing new equipment to comply with shifting regulations takes time. AirReps offers equipment that meets the current regulations and will be in the forefront of adopting efficient, safe refrigerants in the near and long term. Many refrigerant options are being considered. AirReps represents Daikin, where we are committed to utilizing zero ozone depletion potential refrigerants to make the best choices for each HVAC system we help to build and design. As mentioned, HFC production, even those with GWP less than 750, will be phased down to 15% of the 2015 levels. Longer-term refrigerant alternatives are needed. Hydrofluorophens, HFOs, and blends with ultra-low GWP, and in the A1 category, will have the best qualities. A refrigerant that is a single working fluid with low glide can be used in a wider variety of systems. Unsaturated organic compound refrigerant molecules easily dissociate in the presence of light. This means they have an ultra-low GWP values, under 10. They are very similar to CO2. Here at AirReps, we will continue to educate and stay informed so we can make the best choices possible in each of our system designs for your buildings and projects, the longevity of their use, and for our planet.